Hey everyone, my name is CJ Bingham. This is my term project for software engineering, or principles of software engineering. I created an application called Fantasy Football Predictor. So what I wanted to do was use some of the available NFL statistics online and then pull that in, create some rankings just kind of based off of last season, what was going on, what they were projected, what they actually produced in terms of points and that kind of thing. So for this application, I focused on wide receivers. I wanted to start small and then kind of branch out to running backs or quarterbacks or tight ends or other positions in the NFL. And this focuses on PPR. So there's a few different scoring formats in fantasy football, but PPR is kind of arguably the most common. So that's what I picked. And then I essentially created 3 rankings. So I pulled a ranking from Fantasy Pros, so that's like based on their own statistics, and essentially grades all of the wide receivers based on how good they should be this season. So you'll see in the database they'll have like 1 to, I think it's like 174 or something like that, and then it stops grading them. So some of the wide receivers don't have a grade. That's just because they're kind of deep in the roster. And then I have this opportunity versus actual. So this is essentially a due to regress or due to overperform flag for each player. So this is based on last season, what they actually did and what they were projected to do, and the difference between that, if it was something that was significantly above or significantly below, it's flagged. And this doesn't account for injuries or anything like that. This is just based off points alone, so certain players it might not be accurate for, but that was something that I calculated. And then I calculated defense versus wide receivers. So I just looked at last season how well each defense did against wide receivers, and so it'll calculate like a ranking 1 through 32 on if it's like the #1 best defense for a wide receiver to go against, or like the 32nd best. So if you see like 32, that's a really tough defense against wide receivers. So that's essentially what I was doing. So a data pipeline that imports NFL statistics via NFL Read Pi, and then Fantasy Pros ranking, this opportunity versus actual flag, and then defense versus wide receiver ranking. So this was some of the design and implementation constraints. Functional requirements, so the data pipeline, team tracking, weekly view, some of the non-functional requirements. So I was using Streamlit and dbeaver. Dbeaver essentially allows you to have like a UI for Postgres. So it's really easy to debug, kind of see what was going on. Just make sure that there was, a wide receiver, but they had like, a row for each week. So I can have a different ranking in there based on what week it was and what had happened previous weeks. And then this is just some of the system features here, and then moving on. So this is the design document. So moving down here, I define a little bit more about what these rankings are. I also have this right here so you can see. So from NFLverse, this comes in, and I essentially have like this transform layer as these 3.pies. So essentially defense versus wide receiver, opportunity versus actual, and then like Fantasy Pros. And then I had like a load.py that would essentially pull these all and then put them into wide receiver weekly metrics, a table in Postgres. And then user teams was really just coming from Streamlit, like people putting in a username, selecting players that they wanted on their team to track, so you could set up a team of all your drafted players, or players that you want to kind of pay attention to or look at or whatever it may be. So this is architectural patterns, my interaction diagram. This is all my components and how they were going to be designed. So data ingestion. So I had like an extract.py, defense versus wide receiver, opportunity versus actual, Fantasy Pros, load.py, and then the team tracking, weekly view. This is some of the interface component, I guess, our internal component interfaces, external API descriptions. This was essentially like my data frames in pandas. So I didn't necessarily have like data structures, but I dealt with data frames and then just went to Postgres. So this is kind of some of the stuff that I worked with. And then I have my entity relationship diagram. This is just a little bit more detail on the data. So specifically GSIS-ID, that was essentially like the identifier. I had some issues from Fantasy Pros. They have like their own ID system. I guess that's different from NFLxPython or the repositories it gets its data from. So I had to handle that. That was kind of a big bug that came up, but I was able to handle that. And then this is the data flow here. This is just a little bit more detail here, but I'll move on to the test document. So moving down, this is essentially the way I did the testing. So I had a folder for pipeline, I had a folder for web app, which was all the Streamlit stuff, and a folder for database, and then I had these PyTest suites. So I had test FFP pipeline for all of essentially these, and then test web app, and then test database. So I essentially listed the features to be tested and not to be tested. The way I did this was it's like pre-draft, so it's not actually like computing different grades week by week right now. That's something that would be next to do, I guess, for the season that's about to start. But this is mainly for like, hey, I want to draft my wide receivers. Show me like what their ratings are. Show me their like week 1 matchup, and show me if they're kind of due to overperform or due to progress based on last season. So down here I ended up with a lot of test cases. I have like 40 of them, some of them handling like the polars transformation, some of them just handling like just the specific like functions I had tied to different components and things like that. And then I have the results listed below. But essentially, if I scroll down here, I had some manual user tests as well. So this wasn't like PyTest. This was just me going in and testing the offline data pipeline. So I have a screenshot of like dbeaver below of just me running the data pipeline, making sure it works, making sure the data is clean. And then I have some of using the actual application. So if you scroll down, this was my test suite along with my manual user test. Ended up being like 44 tests. This was my test FFP pipeline.py. This is my test web app.py, and my test database.py right here. And then this is what dbeaver looks like. There's a lot more information on these rankings like this way, but this was just a screenshot showing that the IDs came in correctly, that the names, there's 18 names for one per each week. So that's why it's there, so you can compute different rankings. As you go through the season, this is what the Streamlit UI ended up looking like. So you can see they'll show your players down here, what team they're on, who their opponent is, and then the 3 rankings. And then I'll show you that app here in a second. So this is my traceability matrix right here. And then if I scroll down here, let's see, I have this. So this is the command to get the Streamlit application running. I'll go ahead and run that. So this is all local. I'll drag this over. So you can create any username, anything you want. I'll go this a little bigger here. So I'll just do, let's see, CJ Bingham 1. And then enter. So you can browse the wide receivers here. So you can see there's a few different wide receivers, pretty much every wide receiver in the NFL. You can select, like, let's say Puka Nacua. Where do you go? There we go. So I can add Puka to my team. If you scroll, he's due to regress. He did really good last season, but he's the second best wide receiver. And then you can also search. So let's say I wanted to get, let's see, who do I want to get? I don't know. Who's a good wide receiver? Oh, here we go. Chris Olave. I can add on my team. Scroll down. Let's see. He's the 13th best. So this is like 6th best defense to play. So Detroit is the 6th best defense for wide receivers. And then the 13th best is San Francisco. And then he's neutral. So there's not really anything arguable about his production to say he's due to regress or due to overperform. But yeah, that's it. So this is the application running, adding teams. You can also remove them. And yeah, and then the licensing here to show that the data is licensed by CC Creative Commons. So yeah, that's it. Thanks so much.